ऐसी मशीन हम नहीं बना सकते जिसका सोल इफेक्ट क्या होगा, हीट इनटू इक्वल अमाउंट ऑफ द वर्क, मींस हीट इज नॉट रिजेक्टेड टू सिस्टम, मींस सपोज आपने 232 और 333 किलो कैलोरी और you can say 333 from the heat source to the machine, and this 333 kilowatt is equally converted into the work. So it is not possible to convert such heat into equal amount of work, and it is impossible to construct such a machine which can operate in cycle. That cycle means q amount of one is added and you get equal amount of the work. That is about the statement of Kelvin's Planck's. Now the second statement states that it is impossible to construct a machine. Again, same they have to given a machine here also they can add a machine, but it's differs that it differs that which operates a cycle whose sole effect is to transfer the heat from low temperature body to high temperature body without consuming external work. Means it is impossible to construct a machine. हम ये machine हम दिख रहा है आपको, so हम ये machine नहीं बना सकते जिसका इफेक्ट क्या होगा कि जो लो टेम्परेचर से हमको हीट प्रोवाइड करना है हाई टेम्परेचर को, राइट? सो विदाउट कंज्यूमिंग एक्सटर्नल वर्क, यहाँ पे एक वर्क इनपुट दिख रहा है आपको, यू डोंट सी एनी टाइप ऑफ वर्क, सो मशीन कैन नॉट ऑपरेट विदाउट एडिंग वर्क ऑन इट. So it's impossible to construct a machine which operates in cycle whose sole purpose is to transfer from heat from low temperature body to high temperature body without consuming external work. It always requires some external work on the system or machine to transfer heat from low temperature body to temperature body. Now there are some concepts regarding of thermodynamics. You say that it's called as heat engine, heat pump and refrigerator. So here I will explain you that heat engine, heat pump and refrigerator, and you also bring you can say that ready with your notebook for writing some numerical formula also, because formula is required while solving the numericals. I am sharing second screen. Is this screen is available visible now?
No.
Yes,
Yes,
sir.
sir.
So
Yes,
my
sir.
request to all the students who are joining
Yes,
this
sir.
lecture, kindly draw this diagram on their notebook and give the name it as a heat engine. So it's a high temperature source, H1, you can say T1, it's a Q in, you show arrow here, don't arrow यहाँ पे show नहीं कर सकते कि ये diagram में आप arrow show करो. Heat flow from high temperature source, you call as Q in. There is a heat engine, you say HE inside it. So amount of work is done by the system and some amount of the heat is ejected to low temperature sink. Kindly draw this figure. And draw the symbol line also. जो आपको दिख रहा है ऐसे ऐसे ड्रॉ करने की जरूरत नहीं है, आपने सिर्फ सर्कल बनाया, वहां पे आपने T1 भी लिख लो भी चलेगा. You can say high temperature source, you can write it according to your finish in just in 30 seconds. Simple diagram. बिकॉज इट इज अ पार्ट ऑफ योर न्यूमेरिकल. आपको सिंपल सिंपल न्यूमेरिकल्स में भी वहां पे बताया जाता है, ड्रॉ द सिस्टम डायग्राम एंड देन सॉल्व द न्यूमेरिकल अकॉर्डिंगली, सो यू कैन नो. In this case, it's called as the heat engine. So you see that in high temperature source, some of the heat is added in the heat engine, right? So that amount of the heat is to be utilized in the engine to give the useful work. It's called as W net. Once the amount of heat is utilized to done, or you can say to perform the work done, you can say W net. After performing the work done, some of the heat from the heat engine is rejected to the low temperature 6. Is called as Q out. Have you drawn?
Yes, sir.
Yes.
Okay. Now next we have to move that is steam power plant. We taken an example of it. You see that it is a turbine, there is a boiler, condenser, and some pump is there, right? So source is there is a furnace. So heat is flow from high temperature to the low temperature. You can say from source to sink. As you see on screen. सबको screen पे दिख रहा है ना बराबर?
Yes, sir.
Yes.
Yeah.
Yes, sir.
So we can consider as a turbine as a heat engine, right? So in this case, a source of heat, it is a high temperature body. The high temperature body is a boiler, which is providing Q in a turbine. So in turbine, what happens? Some of the work done is happen. Work done happens means the turbine shaft rotates, at it rotates the generator shafts, and work is gets output. But I do know you have learned the thermal power plant in which steam enter into the turbine and it leaves the turbine, right? So that steam leaves the turbine is comes into condenser, that is heat rejected. You can Q out to the sink according to the heat engine concept. So here is the question: can Q out be eliminated? Answer is no, it cannot be eliminated. Without heat rejection process, the cycle cannot be completed, as is the process, the second law statement. जो सेकंड लॉ स्टेटमेंट हमने पढ़ा ना, उसी का ये प्रूफ है. विदाउट हीट रिजेक्शन the process cannot be, or the cycle cannot be completed. So there is always some heat is rejected to the surrounding, you can say atmosphere here. It depends upon different aspects. In the next slide you see that, so for that case, net work output, write down in your notebook, work net or output net is equal to W out minus W in. ये आपको सॉल्व करते समय लगने वाला है ये फॉर्मूला. W net is equal to W out oblique minus work done out, work done in. Each component is an open system. However, as a complete set of components, no mass in oblique out of the system. Hence, it can be treated as closed system. And in closed system, delta U is equal to 0. Internal energy can be different types of energy. Actually, so U is useless for energy. Thus, the formula changes to work net is equal to Q out minus Q in. Kindly note down these two formulas. These formulas will be required to solve numericals. Written? Note down हो क्या बच्चों?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So that's about the heat engine. Now, part of heat output is the converted to net work output is the measure of performance of the heat engine, right? And it is also known as the thermal efficiency. Kindly write down that thermal efficiency of the heat engine is calculated by net work output upon total heat input. In mathematical formula, thermal efficiency, T stands for thermal efficiency is equal to W net output or W net upon Q in. Is equivalent to 1 minus Q out upon Q in. It's simply Q in minus Q out upon Q in, and it can be written as 1 minus Q out upon Q in. Kindly note this thermal efficiency for heat engine. You write down this one. Thermal efficiency equal to net work output upon total heat out input, and then you write it thermal efficiency equal to W net upon Q in is equal to Q in minus Q out upon Q in is equal to 1 minus Q out upon Q in this way. This formula is utilized when we solve the numericals. Kindly note all these formulas. Now we have to move to the next point. in which it can be rewritten as, you see that, Q out upon Q in. So now it is QH, magnitude of heat transfer between cyclic device and source at temperature TH, right? And QL, the low temperature heat, magnitude of heat transfer between cyclic device and the seat temperature TL. So work net output is QH minus QL is equal to 1 minus QL upon QS. Same equation is there, just there to change the notations. So you can also write it as QL upon QH. Once you note down these things, we will move to the next point. Kelvin Planck statement is a clause statement about that. Before going to the one, see here, a heat engine must give away some heat to the low temperature wire, that is called as sink, and to complete the cycle, right? Thus, a heat engine must exchange heat in at least two reservoirs for continuous operation. This forms the basis for Kelvin Planck expression of the law of the thermodynamics. So move to the next part. Kelvin Planck statement. It is impossible for any device that operates on cycle to receive the heat from a single wire or to produce a net amount of the work done. So no heat engine can be have thermal efficiency of 100% because some of the heat is rejected to the surrounding, right? So it's just like that. Simply we can say that your IC engine, internal engines of your four-wheeler or two-wheeler. Always you can use petrol or diesel to burn to give the net work output, but there is some heat is rejected to the surrounding through silencer. So 100% of the heat is not utilized. Some part of the heat is rejected to the surrounding. Got it? It's a simple example of it. Now second part is called as the refrigerator oblique the heat. In this case, you see that work is out from the system, right? So heat injected, heat comes in, Q come in, and it is convert some into useful work out. For the second case, in this case, it is opposite it. It is heat is to be gained from the surrounding and work done on the system. हीट इंजन में दो कंसेप्ट है, अब सॉरी इसमें दो कंसेप्ट है, हीट work done by the system and work done on the system. So in heat engine work done by the system, whereas in refrigerator and heat pump work done on the system. You say that see W net in. So यहाँ पे जो भी आपको दिख रहा है, इस पे जो भी आप देख रहोगे, see this QH and QL. If refrigerator you can consider, so it is pumped into the compressor, so it get into condenser and expansion wall in combustion operator. So it's about the refrigerator work cycle. You see that here is a heat transfer from high temperature to the low temperature region. So if you want to heat the space, you can use as condenser. So spaces get heated, right? Heat pump. If you want the temperature below atmosphere or below the room temperature, so we can use it evaporator to cool the space. Both have the same working cycle. Only the change is that it is moved from room temperature to the high temperature. Depends upon the purpose. आपको स्पेस को गर्म रखना है कि ठंडा रखना है, इस पे डिपेंड करता है. The reverse process cannot be occur itself. The transfer of heat from refrigerator region to the high temperature requires a special device known as the refrigerator, in which both the cases work done on the system to get the desired output. In heat pump, desired output is the QH, whereas in refrigerator, the desired output is the QL. See in the next slide. It is a complete diagram of the refrigerator and heat pump. Whereas if the desired output is QH, kindly draw this diagram. ये अंदर जो दिख रहा है इतना ड्रॉ करने की जरूरत नहीं है. यहाँ पे सिर्फ आप लिखो HP ऑब्लिक R. समझ में आया क्या? ये जो एरो का डायरेक्शन दिख रहा है ना सबको, यहाँ पे हीट टेम्परेचर सोर्स लिखो TH और T1, यहाँ लोड टेम्परेचर सेम T2 और TL, यहाँ पे W नेट का लिखाओ, यहाँ पे लिखो अंदर ये सर्कल के अंदर R ऑब्लिक HE हीट पंप. अगर हीट पंप है तो डिजायर्ड इफेक्ट आपका QH होता है, अगर रेफ्रिजरेटर है तो डिजायर्ड इफेक्ट आपका QL होता है। तो दोनों के लिए जो वर्क होता है वो करना पड़ता है, तभी आपको डिजायर्ड इफेक्ट मिलता है। गॉट इट? गॉट इट?
Yes, sir.
Okay. Now to
Yes,
move to
sir.
the next point. See here, the efficiency of refrigerator is to be expressed in the terms of the coefficient of the performance. So coefficient of performance of the refrigerator, R stand for refrigerator, is the desired output upon required input. So desired output is required QL. हमें जो चीज है उसको ठंडा रखना है। रेफ्रिजरेटर हम क्यों यूज करते हैं? किसी भी चीज को ठंडा करने के लिए, सही है? और टू प्रिजर्व, राइट?
Yes, sir.
To preserve it, so you can consider a desired output effect for refrigerator is QL, and to get that QL we require some input is that work done on the system, right? So according to the first law of thermodynamics gives work net is a QH minus QL. So COP of refrigerator is a QL upon QH minus QL. So COP of refrigerator can be greater than 1. Kindly note all these expressions. Right equation, COP, coefficient of performance, switch to R is equal to desired output upon required input is equal to QL upon Q net. And as per the first law of thermodynamics, W net is equal to QH minus QL. So COP of refrigeration is equal to QL upon QH minus QL. So write these expressions and also write COP of refrigeration can be greater than 1. Once you finish this one, let me know so we can move to the next slide for coefficient of performance of the heat pump.
हो गया सर।
Okay. So right now this was second statement for heat pump. COP is expressed as desired output upon required input is equal to QH upon W net. Whereas COP of the heat pump is equal to QL upon QH minus QL. Thus, you can say that if you remove COP of heat pump minus COP of refrigerator is equal to 1, or COP of heat pump is equal to COP of refrigerator plus 1. आपको एक्सप्रेशन पूछा जाता है एग्जाम में, why COP of heat pump minus COP of refrigerator is equal to 1. So just add this QH minus QL, sorry, QH upon QH minus QL minus QL upon QH minus QL. You get that this equation that QH minus COP of heat pump is minus COP 1. Have you noted it?
Yes, sir.
Okay. सभी का हो गया नोट करके फार्मूलेज?
Yes, sir.
Yes, sir.
Yes, sir.
So I have to change the screen now.
So when you will share this PPT?
Today or by tomorrow, right? It is uploaded on Google Classroom.
सर
Okay,
वो
sir,
नोट्स
okay.
मतलब कोई भी नोट्स नहीं सर अभी तक क्लासरूम पे?
We just
Unit
upload
one.
these PowerPoint presentations. They are self-explanatory. Just your whatever the explanation status are given there. So you just get it from directly diagram and you write in on own words. So I think notes are required for it. Okay. And same thing happens in the examination. So examination भी वैसे ही पूछा जाता है.
Yes, sir.
Now I'm all of you ready with your can say the notebook and calculator.
Yes, sir.
Yes, sir.
I'm sharing one of this tab here. So you see that one of the numericals. So kindly write down this numerical. A refrigeration system is used to maintain a cold storage at 4 degrees Celsius. The heat leakage from the surrounding the cold storage is estimated to be 1800 kilojoule per minute. If the COP of the refrigeration system is 1.5, find the amount of the heat rejected to the surrounding and the power required to drive the refrigeration system. Draw the sketch of the system. It is included for 5 marks numerical. In each numerical, you need to draw the sketch of the system. So according to this word, that refrigeration, heat pump or heat engine given, you draw the diagram of it. So first write down this numerical. Once you write down this numerical in your notebook, let me know so we can go for a solution of it. It is a very simple numericals. When you are facing your internal exams, study in semester exams, they are just added all these things. You just put up the formula, enter the values, and calculate the answer. The 2 marks numerical they can ask in semester examination. So kindly prepare all these formulas properly. So when you are entering the value, you get a correct answer in your in semester examination, which is to be happen in the 2nd or 3rd week of the February.
Done, sir.
Student, have you written completed the problem writing statement?
Yes, sir. Also.
Okay, thank you. So now look at to the problem statement in which they can given you the refrigeration system. So आपको जो
wait a minute.
yes.
Wait a minute.
Okay.
So which book is this?
Priyanka, what you say?
सर पीडीएफ को थोड़ा ऊपर लीजिए.
Just a minute, sir. Can I explain now things?
Yes, sir.
Okay.
Yes,
So
sir.
here you see that refrigeration system is yours. So सबसे पहले आपको वो यहाँ पे लिखा है लास्ट में ड्रॉ द स्केच ऑफ द सिस्टम. सो आपको सबसे पहले जो सॉल्यूशन होगा उसमें आपको गिवन डेटा होता है वो लिखना पड़ता है. सो गिवन इज दैट T2. What is T2? Cold storage. Maintain at 4 degree means out of the two temperature, the minimum temperature is 4 degrees Celsius, right? So it is to be considered at TL or T2. So 4 degrees Celsius and all temperature must be converted into Kelvins. उन्होंने rule दिया है, but in some cases they can utilize it directly as 4 degrees Celsius. But in some mostly 99% they can convert this temperature into 273. Adding by it is converted into Kelvin. So for that case, आपको सॉल्यूशन ऐसे फाइंड करना है कि आपको वर्डिंग समझ में आनी चाहिए. तो रेफ्रिजरेशन सिस्टम इज यूज्ड टू मेंटेन अ कोल्ड स्टोरेज एट 4 डिग्री सेल्सियस. जो रेफ्रिजरेशन सिस्टम है एंड ये कैन मेंटेन अ कोल्ड स्टोरेज एट 4 डिग्री सेल्सियस. मीन मैक्सिमम एंड मिनिमम टेंपरेचर चेक करो. यहाँ पे मैक्सिमम टेंपरेचर नहीं दिख रहा है पर मिनिमम टेंपरेचर दिख रहा है. आपको 4 डिग्री दिया हुआ है. सो इट कन्वर्ट इनटू केल्विन. सो इट्स अ 277. The heat leakage from the surrounding system into the cold storage is estimated to be 1800 kilojoule per minute. Heat leakage means जो भी आपका जो कोल्ड स्टोरेज है, कोल्ड स्टोरेज से हीट बाहर जा रहा है मींस QL. देखो आपको सिस्टम दिखाता हूं मैं. देखो यहाँ से. तो यहाँ पे आपका सिस्टम है 4 डिग्री सेल्सियस पर heat leakage to the surrounding is by means of 1800 kilojoule per minute, and this heat is utilized in refrigerator unit by some work done on it, and after refrigeration it rejected to the Q1 and come into the heat temperature source T1, right? So it's 1800 kilojoule per minute, and you know that COP of the refrigeration system is 1.5, and you have to find the amount of heat rejected to the surroundings, means this one Q1 you require, and secondly the power required to drive the refrigeration system. Power means you require some work done by the system, W. This W is required. So for this, according to this two statement, that is T2 you know that, and Q2 you know that, and you know that in refrigeration system Q2 is the desired effect, right? And you know that COP is 1.5. So to calculate referencing the W, we are using the COP equation. So kindly write down amount of heat rejected to surrounding Q1 is equal to get this one you can utilize the COP of the COP equation. COP of refrigerator is equal to, kindly write, desired output to the work input. So desired output of refrigerator is Q2 upon W. Hence W is equal to Q2 upon COP. So value of Q2 is 1800 kilojoule per minute upon COP is 1.5. You get as W, that is work well done. You can say here that is different from the power, is 1200 kilojoule per minute. And from the first law of the thermodynamics, W net is equal to Q1 minus Q2. So Q1 is equal to Q2 plus W. So Q1 you get it as 1800 plus 10 is equal to 3000 kilojoule per minute. Where you can see the different equation, the power you can say W or P is 1200 kilojoule per minute, and you know that power always you have to express in watt. So to convert it watt, 1200 divided by second, kilojoule per second. Joule per second is nothing but watt. So if you multiply it by 100 also, so it's a joule per second and it's converted into watts. So instead of converting into watt, we just convert this into second. So in minute there are 60 seconds. So 1200 divided by 60, you get is at 2 kilowatt or 2 kilojoule per second, your answer. Before proceeding to this answer, draw this schematic diagram. This is according to your screen. Kindly draw the system. For after drawing this sketch, you write this COP, calculate the answer, you get it or not, then power, you get it at 2 kilowatt. Once you complete all this reading, let me know. So wait for a minute, students. In exam, if you are facing physical exam, so a simple numerical simple diagram ऐसे ड्रॉ करना है जैसे आपको स्क्रीन पे दिख रहा है. हम जब हमें पढ़ा था, हमने भी ऐसी डायग्राम ड्रॉ की थी जो सालों साल से ऐसी चलते आ रही है. सिंपल न्यूमेरिकल जो आपको मैंने पीपीटी में दिखाया वो बहुत ज्यादा एक्सप्लेनेटरी था, उतना जरूरत नहीं है. सीधा समझ में आए उतना एक्सप्लेन ड्रॉ करो. जस्ट नो दैट फॉर रेडिएशन एंड हीट पंप, heat flow from low temperature to the high temperature and W comes inside the circle. For other case, heat engine, heat flow from high temperature to low temperature and work get out from the system. सिर्फ इतना ही चेंज है, बाकी सेम है.
सर मींस टू फाइंड के बाद ये डायग्राम निकालनी है और बाद में ये सॉल्यूशन लिखना है ना.
हाँ, आपको यहाँ पे प्रॉब्लम में दिया है ना, ड्रॉ द स्केच ऑफ द सिस्टम. तो सबसे पहले आपको स्केच ड्रॉ करना पड़ेगा आफ्टर गिवन, देन यू स्टार्ट योर न्यूमेरिकल. बिकॉज अगर आप पहले न्यूमेरिकल सॉल्व करते हो बाद में स्केच ड्रॉ करते हो तो ऐसे कंफ्यूजन होता है एग्जामिनर को, इसको कुछ पता नहीं होगा. सो व्हेन यू ड्रॉ द स्केच पिट फर्स्ट एंड लेबल इट प्रॉपर्ली, दैट इज T1, Q1, W, Q2 or T2 according to you have to see on the screen. So it is not that concept of the student is totally clear and you get total exact 10 out of 10, 5 out of 5 marks for it.
Okay, sir.
So we can proceed to the next numerical.
Yes,
Sir,
sir.
wait a minute.
Yes.
हॅलो सर
Yes.
तिथे तिथे टू कसं आलं सर लास्टला
काय
20 पाहिजे ना तिथे
काय
लास्ट
काय
लास्ट मध्ये पॉवर काढली तिथं टू कसं 20 पाहिजे ना
पॉवर चुकलाय का
हो बघा ना तुम्ही
काय चुकलंय त्याच्यामध्ये
20 पाहिजे ना
या जस्ट अ मिनट टाइपिंग मिस्टेक्स जो लोकल एप्लीकेशन का जो बुक है उसमें टाइपिंग मिस्टेक बहुत ज्यादा है सो अगर कोई चेंज है तो मुझे नोट हो 60 यस इट इज 20 किलोवाट्स यू आर करेक्ट इट इज 20 किलोवाट इंस्टेड ऑफ 12
सही बुक कुठली आहे
ये है टेक्न्यू पब्लिकेशन टेक नॉलेज पब्लिकेशन का बुक है जो उन्होंने हमको एक्सेस दिया हुआ है एक्सेस बुक का ई बुक का सो न्यूमेरिकल से हम यूज कर रहे हैं बस बाकी तो कंटेंट हमारा पीपीटी पे ही चल जाता है सो
Sir.
कैन वी प्लीज डू सेकंड न्यूमेरिकल
यस सर
please write down the statement otherwise we can stop here we can take this numerical in the second lecture okay
Okay,
Sir.
नहीं चलेगा
हाँ,
इतना ही
sir.
काफी है बाकी का मैं लेके रखता हूँ ठीक से नेक्स्ट लेक्चर
हेलो सर
यस
सर मुझे पूछना था सर अपने गूगल क्लासरूम पे अभी कौन सी भी पीपीटी अपलोड नहीं की है ना सर आपने
आपका आवाज ब्रेक हो रहा है सोहम
हेलो
हाँ
हेलो
हाँ
हाँ सर मतलब अपना जो गूगल क्लासरूम है सर उसके ऊपर अभी कोई भी पीपीटी जो लेक्चर की पीपीटी कोई भी ऐड नहीं की गई है ना
क्लासरूम पे आप ज्वाइन नहीं हो क्या मैंने पीपीटी अपलोड किया है न्यूमेरिकल्स भी अपलोड किए बेटा
नहीं सर न्यूमेरिकल दिख रहा है
Unit
मुझे
one से
लेकिन
के लिए।
ये नहीं दिख रहा है सर हाँ पीपीटी नहीं दिख रही मुझे
युनिट वन
Power-
केलं ना सर युनिट वन
ची अपलोड केलेली ना त्यांनी सोहम
हाँ सर पावर प्रोड्यूसिंग एंड पावर एब्जॉर्बिंग
late
वो
join.
यूनिट 1 के
जस्ट ए मिनट एक मिनट देखो चलो रुको यू आर फ्रॉम विच डिवीजन बी ना
यस सर
okay remaining students put their attendance and leave